Welcome to Sir RP's channel. In this video, you're going to learn how to solve oblique triangles using the law of cosine. Are you ready to learn? Sit back, relax, and get ready to learn. Let us first define law of cosine. It states that in a triangle, the square of the side opposite the included angle is equal to the sum of the squares of the two other sides containing the included angle subtracted by twice the product of these sides times the cosine of the included angle. This is just the formula illustrated below. In symbols, we have the formula a squared is equal to b squared plus c squared minus 2bc times cosine A, where angle A is the included angle between the sides B and C, and A is the side opposite angle A. That is the definition of the law of cosine. As you can see, A is the included angle between sides B and C. Okay, so that's part of the definition. So we have the sum of the squares of the other two sides. Since A is here, so the sum of the squares of two sides, we have B and C, then subtracted by twice the product of these sides, which are sides B and C, and then times the cosine of the included angle. Included angle is A. That is if the included angle is A. But we have other forms for B and for C. If we're going to find side B and side C, then their included angles are angles B and C respectively. Thus, we have the formula B squared is equal to A squared plus C squared minus 2AC times cosine B, and C squared is equal to A squared plus B squared minus 2AB times cosine C. Please take note of the formula because you'll be using this later for our solving. But if we're looking for the missing angle, we have this derived formula from the original one already. So to find the angle A, we have cosine A is equal to B squared plus C squared minus A squared divided by 2BC. And then to find angle B, we have cosine B is equal to A squared plus C squared minus B squared over 2AC. And to find angle C, we have A squared plus B squared minus C squared over 2AB. Okay, we have examples later. Note that the law of cosines can be used when we have two conditions. One, three sides are given or the SSS. And two is if there are two sides and an included angle are given. That's SAS. Again, SSS and SAS. The two conditions. We have now the examples. Example 1. In triangle ABC, if AB is equal to 12 centimeters, BC is 8 centimeters, and angle B is 72 degrees, find the length of AC in the measure of angle A and angle C to the nearest whole number. Please take note, we have two sides given and one included angle. Therefore, we can use the law of cosine. Of course, every time we solve for this kind of problem, we need to illustrate first, okay, or draw the figure. Draw the figure with the given measurements. We let BC be equal to A, which is 8. Then AB is just the C, which is 12. And B is the side AC. So we have side A, B, and C, or sides BC, AC, and AB. Let's proceed. Find AC. Since we're looking for the missing side, we use the formula B squared is equal to A squared plus C squared minus 2AC cosine B. Take note, why is it we're using this formula? Because we're looking for side B or side AC. Okay, So I suggest you have to use these sides so that you can easily identify which of the formula can be used. Okay. After that, after determining the formula to be used, substitute the given values. We have b squared is equal to 8 squared plus 12 squared minus 2 times 8 times 12 cosine 72 degrees. We have b squared is equal to 64 plus 144 minus 192 cosine 72. And then, solving further, we have b squared is equal to 148.6687, and then take the square root of both sides to find b, which is now approximately 12. And take note, since we let b be equal to ac, therefore b or ac is just equal to 12 centimeters. That is to complete. Again, this is different from the right angle. Okay, this is an oblique triangle. So we'll be using either the law of sine or law of cosine. Then we use the derived formula for A since we will be looking for another angle. Okay, so going back to the illustration, we have already the value of angle P, which is 72 degrees. We will look for A and C as asked in the problem. Look for the measure or find the measure of angles A and C. Okay? Using the derived formula for angle A, we have this cosine A is equal to b squared plus c squared minus a squared over 2bc. That's why we solved first for side B. Okay, so just substitute the values. A is 8, B is 12, and C is 12. Okay, and then we have cosine A is equal to 0.7778. But this is not yet the final answer because we are looking for angle A. Remember, when you find the angle, you need to take its inverse or the inverse of that function, cosine inverse of 0.7778, which is approximately 39 degrees. Okay, so again, you have here, you have to substitute the values and then substitute the values, solve further, then you'll get this. Take note, this is not yet the final answer because you still have cosine A. What we're looking for is just the value of angle A. For us to solve for angle A, we need to get the inverse. Cosine inverse, that is 39 degrees. And to complete, since you already have 72 and 39 as measures of the two angles, then we just subtract this from 180 to get the value of angle C, or the measure of angle C, which is 69. And that is now the measure of angle C, 69. Okay? That's for the first example. That's SAS. Second example, in triangle XYZ, XY is 10, YZ is 15, and XZ is 9. Find the measure of each angle of XYZ to the nearest whole number. Okay, we have SSS. We have three sides given. Okay. First, illustrate or draw the figure with the given measurements. Okay, you use small letters, okay, to denote sides so that it will be easier later to substitute to for the formula or to look for the formula to be used. Okay, since we're looking for the measures of each angle of triangle XYZ, we'll be using the derived formula. We can use or we can start from any of the angles. So in this example, I'll be starting with Y. Use the formula and then substitute the values. Then, of course, you need to get the inverse of cosine to find the value of angle Y, which is 36. You do the same with the other angles. For Z, the same process. Then you have 40 for Z. And then for the third one, you don't need anymore to use the formula. Okay? You can go directly to subtracting from 180 degrees. That is 104. Again, going back, if the given are all sides of a triangle, you need to use the derived formula to find the angles. Take note that for you to find the measure of the angle, you need to get the inverse of the cosine function. Okay, so that's cosine inverse of 0.8133 for you to get 36. And for z, that's the cosine inverse of 0.76296, that's 40 degrees. And for the third, you just subtract it from 180 degrees to find the measure of angle x. Questions? For your individual practice, here are the two questions. 1. In triangle PQR, if PQ is 45, QR is 39, and angle Q is 118 degrees, find the length of PR and the measure of angle P and angle R to the nearest whole number. 2. In triangle DEF, DE is 42, EF is 46, and DF is 53. Find the measure of each angle of triangle DEF to the nearest whole number. For your answers, please use the comment section. And here is the key point. For the law of cosine, again, it states that in a triangle, the square of the side opposite the included angle is equal to the sum of the squares of the other two sides containing the included angle, subtracted by twice the product of these sides times the cosine of the included angle. We can solve the law of cosine or the oblique triangle in two ways using the law of cosine if the side is missing or the angle is missing. If side is missing, we can use a squared is equal to b squared plus c squared minus 2bc times cosine a depending upon what is given. And if angle is missing, cosine a is equal to b squared plus c squared minus a squared divided by 2bc. And that ends our session for today. Thank you, Quipper, for the slides used in this presentation. Once again, thank you and happy learning. Don't forget to subscribe and click the notification button to receive updates. This is Sir RP.